Observe the reaction of this lung. In a total vacuum, it immediately shrivels and discolors. This is the physical response to the sudden removal of an invisible element that occupies every cubic centimeter of the space around you. Now, consider a scenario where a switch is flipped, and for a brief moment, every oxygen molecule on Earth vanishes. The nitrogen and argon remain in place, but the oxygen is gone. This disappearance lasts for exactly 5 seconds. While that sounds like a manageable amount of time to hold your breath, the absence of atmospheric oxygen creates a cascade of systemic failures across the planet. We exist within a complex web of chemical requirements that we rarely acknowledge, simply because the most vital components are ones we cannot see. This diagram shows the process at second 1. Your lungs expand to draw in air, but look at the interface between the alveoli and the bloodstream. With no oxygen to cross this membrane, your blood circulates without its primary fuel. The body reacts to this sudden drop in blood oxygen immediately. Athletes at peak exertion lose consciousness as their muscles fail, and hospital patients on life support experience sudden cardiac arrest as systems lose regulatory balance. By second 2, the failure reaches our infrastructure. Modern transportation relies on internal combustion, a process that requires a constant supply of oxygen to ignite and burn fuel. Without that supply, engines sputter and stall. This jet engine loses all thrust mid-flight, while cars on the ground coast to a halt. Our industrial world functions on the assumption that this specific molecule will be available to fuel our machines without interruption. At second 3, the ozone layer, composed of O3 molecules, disintegrates instantly, removing our primary shield. Unfiltered solar radiation strikes the planet at full strength. From the ground, the sky loses its blue hue and dramatically darkens. At second 4, observe this molecular model of concrete. Oxygen atoms act as chemical joints holding it together. As oxygen vanishes, these bonds fail. At a microscopic level, buildings, bridges, and glass instantly lose structural integrity. Oxygen is more than a biological necessity. It is a structural component of the materials that form our cities. Suddenly, at the 5-second mark, the switch flips back. Oxygen returns to the atmosphere at its standard concentration. Across the globe, survivors take a deep breath. Pilots begin emergency restart procedures in their cockpits, and hospital systems stabilize as medical oxygen resumes. The immediate return of the air creates a sense of relief, but the return of oxygen does not instantly reverse the damage caused during those 5 seconds. 2 days later, the global impact is measurable. Emergency services and governments are cataloging thousands of incidents that occurred during the brief window of atmospheric failure. Recovery efforts focus on highway pileups from stalled vehicles, aircraft that were forced into emergency landings, and the loss of patients who were at their most vulnerable when the systems failed. A momentary interruption in a global chemical process results in tangible, lasting damage to our infrastructure and our communities. There is a biological distinction between holding your breath and being deprived of oxygen in a vacuum. Severe hypoxia, even for a few seconds, triggers a specific type of physiological stress. The brain consumes 20% of the body's oxygen. When supply is cut, the body prioritizes this neural flow. But in a total vacuum, there is no reserve. The brain loses neurons immediately, marking the start of irreversible cellular damage. For those 5 seconds, every person on Earth experiences the start of neural cell death. It is a biological race against time, where every passing second results in the loss of thousands of active neurons. The most significant consequence of the event is not the damage to buildings or machines, but the internal biological cost of those 5 missing seconds. Modern physics suggests this scenario is an impossibility, but it serves as a method for understanding our total reliance on the chemical composition of our atmosphere. Human survival depends on the continuity of these unseen processes. We are often more focused on external threats, while ignoring the invisible systems that sustain us every second. If you were aware that the world had only 5 seconds to maintain its balance, what would be your first priority? Share your thoughts in the comments, and subscribe to Future Decoded for more explorations of the hidden mechanics of our world.